Now, let's get down to business. Data science. I know data science is a very interesting field that has some might think it's quite new, some might think it's been there for a while. But whichever way you look at it, you might also be new to it. You might have been hearing it, and there are a lot of buzzwords about what data science is, and uh, maybe that's what got you interested, or you might have seen a lot of things on different platforms about what data science is. Now, there are different definitions for data science, but we are going to be, as the course is, let's look at the outline for today. Okay, we'll be looking at what data science is and also what it is not, because it's important that in the defining data science, in helping your understanding of what the subject matter is, it's also important that we help you also understand what it is not, because oftentimes there are some generalizations that people make about what data science is. And so we'll be helping, and we'll be giving a few examples of, we'll be looking at a few examples of where data science have been used to aid you able to visualize what is possible. Then obviously we'll look at part of the course objectives, but the logistics and the rest is CMU, is based on the main course itself in the university. So let's start. Question is, what is data science? Now, it says data science is the application of computational and statistical technique to address or gain insights into some problems in the real world. Now, one thing you would notice is that there are two things there. There's computational and there are computational and statistical technique. But data science is obviously not just statistics. I would like to look at data science as the application of computer science and statistics to solve problems in the world. That's something you can look at, because if by the time we continue, you would find out that really, if you want to say that data science is all about statistics, there are parts of data science that you can't really, that naturally in statistics, that don't come to bear in statistics. But because of the fact that our interest is not just to work with theories, but is to actually solve problems in the real world. That's why the computer science part of it had to come into play and influence some part of it. I think it's this coming together that really gave it so much value, in that you don't just deal with just theories, but you go ahead to look at real problems that really affects people, and how you can use these tools, all the tools that are available, to solve some of these problems. Now, okay. Um, so, says some other possible definition. Like I said, there's statistics, there's obviously data processing, machine learning, scientific inquiry, visualization, business analytics, and big data. Now, obviously, I think it was the Harvard Business Review that said data science is the sexiest job in the world and stuff like that. And it's really attracting a lot of attention. But one thing I need you to understand is that data science is not necessarily just a job role. I want you to understand that data science and data analytics as a whole is a way of thinking. It's a way of thinking. In fact, I dare say that most roles going forward will have data science elements to them. I'll give you some instance. Recently I on LinkedIn, I was looking at on my feed, a guy dropped a post. He's actually a law student. I think he's doing his master's in law, and he said he had a lot of materials to go through in preparing. That's all the course content. In the legal profession, they have a lot of theories, large notes, and stuff like that. And he happened to be someone who, even though he's a legal practitioner, he's also adept at things like machine learning, data science, basically the core areas of data science. So what he was able to do is he used deep learning and machine learning to summarize the large content he used some NLP techniques to summarize each of all those contents he had, and was able to create a word cloud that gives him a description. That's the basic keywords that were really the crux of the materials he got. So it made his job easier. So these are the kind of things you will find that data science is being able to do. But think about it, he's a legal professional, but he's applying these same principles of data science, in machine learning, in deep learning, to make his job more efficient. So this is where we are really going to. And there's a story also about I can't remember his name. Also, he's a medical doctor. He deals with the eye. He's a Nigerian, but I think he's based in the US, and he created an app based on deep learning and principles from data science, whereby he can use the app. If you snap a picture of your eye, it can analyze to know if you have a certain eye ailment, and be able to tell you if you have a certain eye disease or not. And what this has been able to do is it creates efficiency in the system, such that since in places like Nigeria, we have a very the patient to doctor ratio with respect to doctors in Nigeria, because a lot of doctors are leaving the country, is very high. So you have a lot of patients for few doctors. Now, the way it is now, the doctors spend time diagnosing and also treating, which creates even more workload for them, considering the fact that they are few. But creating a system such as he did ensures that this machine learning system, deep learning system, can do the diagnosis up to 90, I think it's about 95, 96% accuracy, such that it whittles down the overall number of people that will eventually get to the doctors for treatment. So those who don't need any help, who don't have any issues, will end up not getting to take the time of the doctors. These are the kind of real world problems that eventually can be solved with machine learning, data science, with data science principles. Now, what data science is not. Now, it's important that you know that even though there is machine learning, but data science in itself is not machine learning. Machine learning is a subset of data science. Machine learning is one of the ways that we apply data science to solving real world problems. Although I must say that in most cases, you'll find that machine learning might actually be one of the most, we hear a lot about machine learning and the impact that machine learning has on several things. Like the two examples I have given now were mainly machine learning examples, because one thing that happens is that when there is a new subject matter, the most advanced areas in that subject matter get all the attention, but there is still a very large percentage of what makes up data science that is not machine learning, because machine learning involves the computation and statistics. Now, let me but machine learning focuses more on fancy algorithm. But let's really look at this. This image lets us see, really, in most cases, it is this 5% in between that gets to be talked about, because from what we know, 50% of the problem cannot be solved using our unsolvable problems. Now, of the 50% that is left, a large part of it can be done with just simple, if at all, any machine learning work. In fact, in most cases, most of the work you do is just to analyze data and visualize it, and it will end there, and it solves business problems. But there are, in certain cases, about 5% of the time where you need advanced state-of-the-art machine learning models to solve those problems. But the truth of the matter is that these 5% get a lot of traction in news media, and it's easy to talk about. So it looks like all that data science is those very small area, but that's not all it is, as we will get to see as we go along. Now, also, I know that many of us would have heard about cargo competitions, but really, the cargo competitions, I must say, they have their place. As somebody who is new to the field, they will help you to fine tune, help you gain knowledge, and help you to fine tune your capabilities in machine learning and in data science in general. But it's important that you understand that that is not all data science is about. There's much more, and oftentimes cargo competition ends up being about optimizing your model to get even the smallest of to increase. For example, you have an accuracy of let's say 90% or 99%. Oftentimes in cargo competition, you want to squeeze it from 99 to even 99.9. But the challenge always is the fact that in the real world, it might not, that the model you built to get 99.9% accuracy might not be, how would I put it? The cost to benefit ratio compared to maybe a model of 95% accuracy might make more business sense to implement a model that is maybe 92, 95% accuracy than one that is 99.9. One that comes to mind is there was a cargo competition done for, I think it was Netflix. Netflix wanted to increase the accuracy of their recommendations, and some guys eventually were able to do that. But the problem was the algorithm they came up with and their solution, which was highly accurate, was computationally expensive, such that it didn't make business sense for Netflix to implement it, even though it was more accurate, but it was going to end up costing them so much money to implement it. So they eventually didn't. So these are some of the things that can happen within a competition that might not necessarily be applicable in a business sense. Because at the end of the day, business is about a return of investment. You don't just want to do something that is more accurate, but the accuracy itself, does it aid the business in making more money? For example, if I have a very accurate model that is very heavy, such that when people use my site, my website, it takes a lot of time for that model to be processed and to give results. Nobody will want that, because that time that I spent, while I could get something that a little bit less accurate but can perform the function speedily. Obviously, the business will go with something that is faster in that case, because it makes business sense. Because if I come to a site and it's taking so long for it to load, I might not even get the opportunity to see that this thing is accurate, because I might get pissed and walk away and leave the site. So at the end of the day, the business ends up losing customers. Now, also it's important to note that data science is also not statistics, even though there is statistics in data science. The reason the reason being that there are areas of data science that are not directly applicable to statistics. For example, one big example is the areas around web scraping and word processing. Now, that is why you see that those areas, web scraping and word processing, are more computer science aligned. That's why it's important you note that it's a, data science is a fusion. It's more or less a fusion between computer science and statistics. Though there are little other elements that contribute also. Also, data science is also not big data, because it is not compulsory that you need, it's not every time that you need large amount of data sets to make decisions. Sometimes you just need small amount of data to make the decisions as quick as possible, while other times you also need large troves of data to make decisions. So it's important to also bear that in mind. Now, one thing you will notice here is Now, this is the easiest way to look at it. The workflow. There's a data collection part of it. There's a data processing part of it. There's an exploration and visualization part of it, and then there's an analysis and machine learning. Then, but the end result, remember, we are talking about solving real world problems. The end result should be some kind of insights that leads to decision making, that influences policy decisions, either in government, in business, and in different areas of life. That's why the emphasis is on real world problem, because sometimes statistics dwells on theories, but the whole essence of data science is to solve problems that are real, not just theories. Now, this is a very, very clear distinction that you have to draw between data science and statistics in some cases. Because if all you do is have sophisticated models, write great levels of code, and it doesn't solve any problem, all it is just theory. The idea must be that from all that the analysis you have done, the visualization, the machine learning application, that a problem is actually getting solved in the real world. Now, there are quite a few examples of data science application that we'll just go through, and then I'd like to hear back from you if you had any comment before we get to the next topic. Now, one area, if you look at the visualization here, you would see that this is data science, but no machine learning was applied. No machine learning was applied. What basically happened here was they were trying to look at reviews, professor reviews, and they were trying to look at the language of male and female students who were reviewing their professors. They were trying to look at the pattern of the use of language amongst male and female respondents. So what they tried to see is, in reviews of professors, were there language that were more likely to be used by females compared to males? And as you can see, there's a clear difference between the languages used and to what extent it was used by females, which are orange colored, compared to males. So you see that the males tended to use the language, certain languages more. Now, this is just one application of data science, and to be able to do something like this, you need to do some level of web scraping, because obviously the reviews will be done on a website, and you might have to generate the data from those websites and do some NLP, natural language processing, to process it and get these keywords, and then visualize it. Now, another place you can look at is there's a website called 538. Now, it's a very, very important website, especially in the US, with respect to making predictions about politics. But they are not just centered around politics. They are basically a company that use a data influenced approach to make decisions with respect to, for example, in this case now, they are looking at the likelihood that people will vote one way or the other, either Democrats or Republicans, based on surveys and stuff like that. So these are some, and you can see in this case now, there's no machine learning involved. It's just basically they extract the data, they process it, and they visualize, and that's it. Based on it, they were able to draw insights that you can see that the insight shows that there was a 7 in 8 chance that the Democrats will win control, while there's a 1 in 8 chance that the Republicans would. So 87.9% compared to 12% for Republican. And eventually, when the elections were done, in 2018, it was found that they were largely correct in their estimation. So these are some of the things that you can do with data science. Another thing now is something related to poverty mapping. Now, this one was basically done using deep learning, because what it basically did was to distinguish between different kinds of roofs. They used satellite images and used it to train certain deep learning models to be able to decipher. And what basically they were looking at was the type of roof in a particular neighborhood. Obviously, certain kinds of roofs tells you that this is a neighborhood of rich people, because the kind of roofs, more expensive roofs, were in the richer neighborhood compared to poorer neighborhoods, where the roofing they will use will be quite different. But based on satellite images, they were able to map areas of poverty and areas of wealth just using satellite images. This is now when we talk about deep learning and stuff like that. So what these examples show us is the fact that there are applications of data science that are very, very simple to do, that really you don't need to apply machine learning or deep learning to, as we can see with the examples, the first two examples. While also there are areas where you need advanced algorithms, such as deep learning algorithms, to make such decisions. But in all, it's important that you note that at this beginning part, in this data science cohort, we will deal more with the first two examples, in that we are looking at the data science, the beginning part of data science. It's only, I think, in the ninth class, in the eighth class rather, we will have some introduction to machine learning. The idea being to prepare you for the next cohort, where you would likely graduate to the machine learning class. But in all, what we'll be looking at is, if we go back to these different stages, we'll be looking at data collection processes, such as web scraping, data processing. We'll look at databases, relational databases, and obviously we'll look at exploration and visualization, different kinds of EDAs, because and then we'll look at some analysis. But we'll only do just an introduction. But this course is not going to be centered around machine learning. We only tell you about some introduction to machine learning. But in all, we'll be concentrating on this 5-stage process. But in the fourth stage, we'll concentrate more on analysis and then come up with insights. So there will be a lot of visualization, because it's important that you realize that visualization can be descriptive or prescriptive, in that some visualization you do is to understand the data, and it's for you, while some of the visualization you do is to explain what you found out, and that one is geared towards your target audience. So we'll look at those different kinds of visualization, and most of your project will be centered around things like this: analysis, visualization, and the likes. Now, okay, I think okay, like I said, after taking the course, you should understand the full data science pipeline, be familiar with programming tools, and accomplish different portion. We learn about relational databases, graphs, and matrices, a little bit of linear algebra, and being able to do it in Python. We'll know and explore, visualize your data, be able to analyze your data rigorously using various statistical. Uh, we will not be dwelling on this last aspect of it, like I said. So these are some of the topics that are covered, but obviously you have to. This statistical modeling and machine learning is not part of it for this particular cohort. Now, what the rest of it has to do with the CMU. So what I'd like to do now is to find out from us, does anyone have a question? I would like to get feedback from us. So far, do you have a question? Because we still have some time. Let's spend the next 10 minutes getting questions or feedback from you.
Yeah,
So if
hello,
you have a
sir.
question,
Hi.
go ahead. I can hear you. Go ahead.
Okay, I actually don't have a question, but I noticed that the slide you're using, I don't have it. What I have is the Jupyter notes. The introduction part is showing the Jupyter notebook, not introduction like you just did.
Okay. I think the link. What you can do is this.
Yeah.
If you go to the link for notebook, not the slides, go to the link for the notebook. You can now go to what do you call it? Hold on. I think there was an error in the link that was attached to the introduction. But if you go to lectures, just follow the link for the notebook. Then, if you look at the top of the website, you see the area for lectures. Then you see all the course materials. Then you can take the slide for introduction from there. Sorry about that.
Okay. Thank you.
So, hello, sir.
Okay, go ahead.
Yes,
Can
sir.
we do something, please? Uh, Before you ask your question or make your contribution, just kindly just tell us your name and then what your question or contribution is.
All right. Good afternoon. My name is Mubarak. Can you hear me?
Yeah, I can hear you, please. Go
All
ahead.
right. My name is Mubarak. So,
All right.
while he was presenting the introduction, there are some slides I looked at and was able to infer that from this conclusion, machine learning wasn't used. From this conclusion, they used deep learning. Is there a way by just looking at the result, you're able to conclude that this analysis, machine learning was used for this analysis, this was used for it, without even having the data or anything?
Well, here's the thing. Look at it from your own standpoint. You are the one going to be doing the project. Think about what they were trying to achieve here. Let's look at, I'm sure you're talking about these two slides, right?
Yes,
This
yes.
one I presently on. Now, if you read through it, you would find out that what really basically happened was they were trying to um, see what kind of languages, what kind of words were more in line with female or male gender. It's just like now, a couple of us make statements, and they try to look at what statements are more um, how will I put it, are more likely to be made by a female, and what statement is more likely to be made by a male. Obviously, as you can see from here, what they basically did was, you can see that this is a visualization. This is not a machine learning model. They visualize their information to show you what exactly is happening. They process their data and then they visualized it. They didn't need a machine learning. It's not a predictive. They were not trying to predict. They were just trying to describe. I don't know if you understand me.
Okay, sir. Let me make a little contribution.
Okay.
Also to determine factors sometimes that if it's more of a deep learning, machine learning, or data science. Sometimes is the type of data that you see in the analysis you get. So, for example, if you have like the data is in a structured format, you can know that okay, this could be structured data like the ones we have like in a CSV files and stuff like that. You can say okay, this can be done with data science or machine learning kind of. But if you go to unstructured data, when you have things like pictures, voices, languages like text and stuff like that, when the data is not structured, unstructured data, and that's when you can start seeing things like deep learning analysis, because that's where they excel. So sometimes to the type of data, the kind of data shows like give you a hint of how the type of application that is being done. Get So that's also another stuff that you can also watch out for, type of data. So you can read more on structured and unstructured data.
Okay, thank you, Brain. I think also it's important that you realize that now let's not look at this from a theoretical point of view. Let's look at it really. Usually, before you embark on a project, there's a problem or there's an interesting thing you would like to find out about. Now, when you set out to solve the problem, the first thing you look at is what kind of data is available, if any. Then, if there's no data available, you can say, can I presently available? Can I collect data from somewhere? Or is there somewhere that the data is? Or can I go through the process of collecting this data? Now, obviously, the problem you are trying to solve will also play a role in if you're trying to use just data science. For example, if you work in an I'm a data analyst in the office, and now we have our customer information, and basically what we want to do is do some sentiment analysis. We basically want to know which customers are saying things that are positive and some that are saying things that are negative. Like Brain said, that is unstructured data, is text. We might need very little. It's not necessarily yes, then we can apply machine learning after doing a lot of processing. But think about it this way. We might not need to even get to the level. What if we want to look at the kind of problems that our customers talk about? We may not need to get to machine learning. We might just need to process the information, process the text, and come up with a word cloud. The word cloud will basically give us like a representation of the most important keywords that come up in our conversation with our customers. So in that case, all we did was to get a visualization. But if we wanted to go further and say, okay, what is the sentiment of these conversations that our customers have with us? Are they negative or are they positive? Then we might then need to apply machine learning to get to. So the kind of problem you are trying to solve also plays a role in what kind of technique you would apply. Now, in this case, now they were not trying to predict who will vote. What basically this is they get data from polls. Basically, what happens is that they poll individual, but obviously in polling individual, they use some statistical principles. For example, what kind of sample size is the sample representative of the general population? Those kind of things, in making those decisions, they use statistical principles. And when they were done polling, based on the results that the people gave them, the people they polled, they now analyzed the information and came up with visualization that tells you the likelihood based on the response they got that people will vote this way or that way, and then they represented it in something like this. So you can see that in this case, no machine learning is needed because this is not a predictive. They were not trying to do prediction based on machine learning, but they were just looking at the polls to see in which direction people are going based on their response. All they did was to analyze the data and visualize it. So I don't know if we've been able to answer your question. I think it was
Yes, you have to an extent. Thank you very much.
all right. Who else has something to contribute?
Hello.
Yeah, I can hear.
Hello.
Go ahead. Yes, go ahead.
I'm Michael.
Okay, Michael, go ahead.
So I want to get this aspect of prediction and visualization of data. You said something. The thing is, I want to get this concept of okay. When you want to predict data, you use machine learning or use data science only for visualization. Like I didn't get that concept very well.
Okay. Now, it's important that you understand that data science is machine learning, even predict. So, okay, here's the thing. There's something we call predictive analytics. What you are basically saying in that extent is in predictive analytics that you start to use things like machine learning and deep learning because you are trying to predict something. Now, predictive machine learning is a part of data science, and if you look at what is on our screen now, you'll see that there's a total workflow, but the predictive part of it is only in the fourth area. But this entire workflow is data science, data collection, data processing, exploration, and visualization. They are all part of data science. But when you talk about predictive machine learning, deep learning, they are all part of this fourth area, but they are not even the whole part of the fourth area, because you can do analysis without doing machine learning and deep learning. You can do a lot of analysis without machine learning and deep learning. Okay. And that is what he was trying to explain here, whereby there are problems that are unsolvable. Then there are now problems which make up about 50%, which can be solved easily. Sometimes with very simple machine learning algorithms, 45%. But there's now a 5% that needs state of the art, which is what we talk about a lot. But this 45% can be done with just simple visualization. In fact, in most cases, what you find out is that a large percentage of what you will do in the analytics space will not involve machine learning. Especially when you are beginning. In fact, in the data science space, a large part of it is not machine learning centered. There's a whole lot that has to do with visualization, analysis and visualization. They are critical. And the funniest part is, even if you are going to be doing anything on machine learning, you need to do proper processing, data processing. In fact, you have to do data collection, because without data, you can't do any machine learning. And if you don't process your data also, machine learning will be useless, would even give you the wrong result. So all these areas are quite critical. So let's not concentrate so much. Yes, I know what gets talked about and hypes people's attention is the machine learning part of it. But as it is said, and I have experienced based on my work experience, is that a large percentage of what you will do in the data science world has to do with data processing. Sometimes we talk about data cleaning, because data will not always come in the format that you want it or that you need it to do what you want to do. So this area of it, this fourth area of it, makes up a very small percentage of the work you do. But a lot of times, I was listening to someone and he said that when he got his first machine learning jobs, he had learned so much about algorithms and stuff. And all the courses he used to do, they used to give him clean CSV file, clean data set. But when he got on the job, he now found out that they gave him a data set where the data was not clean. When we mean clean data set, it means it's not in the format where you can now apply your model to it. There were a lot of things you needed to do to get it to that level where you can use it for modeling. So these other areas are quite essential, even though what gets talked about a lot is machine learning. In fact, when the hype is being generated, it's around machine learning. No, because obviously data processing and all those things might seem boring. But another area that is very, very, because at the end of the day, even if you do a machine learning, except in the cases where you are applying it directly to systems, because it's important you know that sometimes you do your machine learning models to make business decisions. Sometimes you do them to apply them to systems. Let me try and see if I can come up with an example. Now, this poverty mapping project, obviously, the entire area of using the deep learning will be done, but in presentation to the policymakers that ensures that policymakers can use their results to be able to plan. They will not be presenting the algorithms and the models to the policymakers. They will now have to condense their results with some necessary visualization and communication so that the policymakers will be able to understand that if you notice this, this is what can be applied so that it can be used. So because the end users of some of these things will end up not being people that are very, very adept at the technical part of it. That is why it's critical that if you, one of the characteristics of a good data science is not just that you understand numbers and how to tweak models and algorithms and stuff, is that you are also able to communicate it to your audience, whether it's the policymakers in government or your team lead or the executive, the C-suite executive in your company that then use those decisions, use those insights to make decisions for the company. They don't care about the state of your algorithm. What they care is what does it say in English, in a language they can understand, such that it can help them make good decisions that will help the business generate money. That's what is critical. So who else? Is there any other person that has I see that some people are dropping their messages.
Okay. So to also add to what Sir Ikechukwu has said, also something I need to know is that data science in general is like trying to get insight from data. So you have to really have to understand your data to get insight from it. So data science, machine learning is a subset of data science. Deep learning is a subset of machine learning. So everything is boiled down onto the data science horizon on a broader scale. So for you to able to since machine learning is a subset for data science, for you to really apply those algorithms, funny enough, for you to apply different machine algorithms is not really demanding, like he said. It's just few lines of code, and maybe you want to parameter tune and do stuff like that to your models. But the main part of the machine learning workflow is data preprocessing. You have to understand your data for you to clean it. For example, you need to know distribution of your data for you to do some certain tasks that you need to do. So that's why he's stressing the point of for you to understand your data for you to get insight. For example, if you don't know a language, you won't understand what an insight is or what an insight is not. So you need to understand the data science language, to understand your data in itself. Yeah, so that's what I was trying to iterate. So I hope this one also drives the point that it's very important for you to understand your data first. Understand? That's why most times it's good for you to start from the data science point of view, so you understand your data before you gradually move into the machine learning aspect. You need to understand your data, very important.
I can see that Kehinde, Alimi, and Tosin Ade Lowo, you guys have questions. So I'll take Kehinde. Kehinde, unmute yourself and ask your question or make your contribution, whichever one it is. Kehinde, are you there? Kehinde, Alimi, and Tosin Adelowo. Do you guys have question or I should go ahead? Okay. I guess they are not there. Okay. So does any other person have any questions or contribution? So we can go ahead to the second part of.
That's it.
Huh? Olumide. Uh, I thought Olumide had a question or a contribution. All right. So I'll stop sharing and share a different slide.
Hello.
Hold on, please. Okay.
Okay, I have a
Can you?
question.
Okay, go ahead. Go ahead.
I want to ask, what are we focusing at? Are we? My ad network, so I couldn't get some things. So are we using
Okay.
Python to? Are we using Python to as our tool for programming language, or are we using how?
This course is based on Python.
Okay. Okay. Okay, sir. Thank you, sir.
If you are asking that question, that means you didn't do the. I hope you did the
Solo.
solo learn part before you got
Yes,
on the course.
I did it solo, sir. I did it solo.
All right. Now, now we're just going to be talking about a tool basically, because Jupyter Notebook is a tool that we use to it's a very important tool in the data science community, mainly because of its interactivity. It's very interactive. You can easily write your line of code and get the output needed right there within the tool. So it's one of the go-to tools in data science. I'll just run through this slide, then we'll obviously run the notebook. Okay. Okay. Really, this part of it where it talks about Python 2 or Python 3, this course is based on Python 3, and hardly, very few people actually, most people coming newly into the data science field go ahead and just learn Python 3, because a lot of the Python 2, I personally didn't bother learning Python 2, because a lot of the code base in Python 2 are being transferred to Python 3 now. So now, why Python? The argument in the data science community about Python and R, for me, I think it's unnecessary. It's really unnecessary, because both tools have their advantages and their disadvantages. But for this course, we'll be concentrating on Python. One of the reasons why Python is beloved is because it has a very large community which is still growing, which is really, really growing. And because of Python is very, very flexible. You can use it for a whole lot of stuff. So, as you can see, compared to R, Python is really growing. And the user base, obviously, is quite large. Now I have to ask a question. How many of us have installed the packages that are necessary for this course? Please, a show of. Does someone have a question? Someone says they can't see my screen. Can you guys see my screen?
Yes, I can
Yes, we
see.
can.
Yes, you can.
Okay.
I can.
Yes, we can.
Now,
It's showing Anaconda.
okay. How many of you have Anaconda installed? Please, I need a show of hands.
I
I have Anaconda installed.
Please, just a show of hands so that I can know how many, the percentage of people who do. Aha. I don't expect that anybody's hand is down, except the people are connected and not listening. Who is King James?
Aye, sir.
Huh?
Aye.
Okay, King James, you don't have Anaconda installed?
I have it.
Oh, okay. That's why, the reason I called your name, you are one of the people with their hands down. There are quite a number of people, including Olumide, who asked me the question earlier on. Don't you have Anaconda installed? Anyway, that's fine. You can bring down your hand now. So we know that a large percentage of the people in the class have Anaconda
No, I have
installed.
Anaconda installed, sir.
Okay. That's why I said a show of hands so that I know the people who do. But never mind. We've already brought down our hands. Now, The reason we talk about Anaconda is it makes life easier for you, because if you go through the process of installing Python and all the packages you need individually, it can get complicated in some cases with respect to certain packages. But Anaconda is a distribution that has most of the packages you would need for at least for this course. It has most of it already pre-installed, and I want to believe that most of us have even had a feel of it and have likely installed the packages. And but obviously, if you have challenges, you can ask questions on the forums and we can see how we can help you. Now, the course will be mainly centered around the Jupyter Notebook. Um, I want to also believe that most of us have, okay, by a show of hands, how many of us have ever used the Jupyter Notebook? Just raise your hands. We have 42 people. This is 1, 2, 3, 4. Uh-huh. No. So,
You say I don't know how the raising of hand is taking over.
oh, you
Like,
don't? Okay.
yeah.
Hold on. Let me see.
Click on more,
Uh-huh. If you're
and then
using
you see
your
raise hand.
if you're using your phone, obviously click on more. You can see raise of hand. So okay. Okay. Now that's good. It means that quite a number of us have used the Jupyter Notebook. So we're going to just be running through this because the expectation is that you've obviously had spent some time on Jupyter Notebook. So we can go to, let's just browse through what's on the slide. We will get some time to Kene will obviously be talking to us about the homework and how the submission did right, but not we'll have time to discuss about this part. Okay, this is the polls. Okay, there's really not much. Let's go to the notebook. Let me stop sharing and just go to the notebook. Now, I'm sure you can see my screen. This is a typical. If you've never seen a Jupyter notebook, this is what a Jupyter notebook looks like. And every Jupyter notebook comes with the .ipynb extension. So if you ever see a file that the type is ipynb file, that's a Jupyter notebook. Um, and obviously, I wouldn't want to go through the process of. There's a simple process for starting your Jupyter notebook. It's not that complicated. If you have an issue with it, obviously you can chat one of your colleagues up, and or drop a message on Slack, and somebody will likely guide you through it, or preferably we might just provide a link where you can just find a video that will direct you to through it. So it's important that if you have any challenge, that don't it's important that you note that irrespective of all the people raising up their hand, in case for any reason you are, because everyone in this class, we are not likely to be at the same stage. So if you need help, always ask for help. It's one of the essential reasons why you joined a community like this. But what I always say to people is this, which is why I made the statement I made when we started the class. Go through the material. Go through the confusion that comes from accessing an information for the first time. When you come across an information for the first time, your brain is not used to it. So there's a tendency for you to look confusing to you. But that is absolutely fine. It's part of the process of learning. But the challenge is that we often avoid that stage because it's uncomfortable for us. But it's important you do it if you want to learn anything. That's why it's important you watch through the course material, you watch the video. whatever you don't understand, or especially like this introduction and the Jupyter part of the class, most likely will not be a challenge. But when we start going into the harder part of the class, especially when we start getting to the areas, depending on the level of your previous knowledge in data science before coming into this program, you might find some of the materials will be very, very, they may seem confusing, but that's okay. That's why I would rather prefer that the first confusion you have is while you are watching the content, such that you come into the class with certain questions, because when you don't understand something, you can note it and say, I didn't really understand what he was saying here. And it makes the class more interactive because you come armed with questions to ask during the class. And one thing you will notice in data science is that if you ever find anybody that knows everything in everything in data science, it means that that person doesn't know anything. Even me as your tutor, there are questions you bring to me, I'll have to go and do my research to find answers to. And that's what we expect. We expect that you bring questions that are quite challenging, that will challenge us to even further broaden our horizon, because the essence of teaching is learning. I can't know everything, but your own experiences, the challenges you have as you learn and you bring them into the class will aid all of us, the total experience for everyone in the class. And we will end up gaining more if it turns out that I have 40-something scholars who are actually doing their own work. I'm coming to challenge some of the things I say and say, you said this, but this is what I learned. And we can have a back and forth discussion about these things. And you can ask questions that if me and brain can't even answer it, or nobody in the class, it becomes something that we all go and research on and come back and gain new knowledge and move forward. That's the whole essence of the community. In case you didn't know, maybe I like to say it to students so that it helps some people who are new and wondering. Now, I used to be a structural engineer. Till 2017. 2017 January, okay, 2018 January was the first time I did my first ever data science course. I was a structural engineer. I had worked for years, but I decided I wanted to change career, and I went and I started learning data science from 2018. In January 2019, I joined AI Saturday for the cohort in January 2019. So I was a student like you in January, between January and I think it was June 2019. I was a student myself in AI Saturday. It was towards the end of that year of 2019, I got my first data science job as a data analyst. Then January this year, I switched job. I got 2 offers and I started another one this January. So in case you are new to this field and you're wondering, I also started from somewhere. I have not always been in this field. In terms of work experience, practical work experience, I have less than 2 years. So don't make it look as if it's not rocket science, but it needs commitment. And that's why if you want to get the best out of this, go through the materials before you come to the class. It will be more beneficial to you like that. So it's not that deep. So if you look at it, basically, if you run the code cell, you can basically see that 1 plus 2, these are things we should know. The print statement, they are basically things you should know. Then this one, you are basically saying for I in range 10. You might be wondering, remember in Python when we're talking about numbers, we don't start from our indexing, doesn't start from 1, it starts from 0. That's why you say for I in range 10 gives us 0 to 9 when you run it. Now, there are obviously packages such as request. We'll use a lot of requests when we are doing, in next week's class, when we are doing web scraping, which is a very, very interesting topic. And I think a lot of, because this cohort is just data science, a lot of your projects, one of the most interesting projects you can do in this class would mainly be centered around web scraping. I remember earlier this year, I scraped the Cars 45 website. I got all their cars. I think there are about 4,000 different cars, models they have, their prices, and all other conditions. And I could do analysis. I didn't end up doing any analysis on it, but I could have easily used it for analysis. So these are some of the things. It's interesting. So when we get to that point, we'll use things like request. So this is a function. So basically, the Jupyter Notebook, basically, the reason why it's really interesting for data science, as you can see, as you run a cell, it gives you an output immediately. It's easy to quickly make whatever mistake you want to make, go back, because data science is a very iterative process. It's an iterative process. Sometimes you do it, you won't get the result, you go back, you run it again, you make some changes, you run it again, you test and retest until gradually your results start going in the right direction, until you eventually get what you want. So that's why Jupyter Notebook is one of your go-to tools. But in using Jupyter Notebook, it's important that there are parts of it that you might find that they are not Python. They call them magic. For example, this is a percentage sign, and time basically helps you time how long it took for your command to run. For example, this sum, this is this is something you could say like a list comprehension. So you say, give me the square of all values of x in a range. Please, who is that? Please, come on. Please, I need to appeal to us. If you know that you are in a noisy environment, just mute yourself. It's better that way, because what you know that we are actually recording this, and it's not nice that we get those kind of interference. Okay. All right. Now, so this basically what this time helps you do is to know how long it takes for this to run. But these things are mainly critical when you probably are trying to optimize your code and stuff like that. They are not necessarily, I wouldn't say they are the one that, funny enough, he didn't bring it up here, that you end up using a lot. But you use it a lot when you are doing visualization. This is the most, I think, this is the magic command I use the most. Matplotlib inline. What it basically does is, okay, I think you'll see it later on here. As you can see, it's here. If you don't do it, these visualizations will not plot within this environment. So that's basically what that does. But what I'm trying to show you here is that there's quite a number of things you can do with Jupyter Notebook beyond, but I would rather say this magic, except for Matplotlib inline and a few others, they are not necessarily critical right now for you. They are not necessarily critical. For example, this particular one, I'm not even sure what it does. But basically, it has to do with the load extension line profiler. It looks at each of the lines of code you are doing and profiles it. So, but let's go to the Python part of it. Obviously, you have lists, you have list comprehension and stuff like that. Obviously, you know a list. This is a typical Python list. This one is a list comprised of strings. Why this is a list comprised of integers and strings, and also a list. So this is basically what you call a list. List 2 is basically a list of lists, because within it is also another list. And obviously, if you went through the solo learn class, you should be able to little by little manipulate some of these things. And that was why it was even critical that you went through these things, so that if you had issues, because the idea is not to teach you Python. The idea is not to teach you Python, but from the class, your Python should improve. So you should have had questions by the time you were coming here. For example, you see that when you print the first list square bracket 0, basically prints the first value in the list, in which case it was A. -1 prints the last value, which is D. Why this third command print list 1 column 2. So basically what you are doing is you are looking at from 1 to 2, 2 not included, where 1 is the second. Remember, in Python, 0 is the first, 1 is the second, and 2 is the third. -1 is the last. So this third command basically says, give me the first value between the second value. Basically, this one gives you the second value only in the list, because it doesn't include that the third value, which is 1 here represents B. Ordinarily, if it was just 2, it will represent C. But in this case, this slicing is only asking you for 1 value. If it was 3, if it was 1 column 3, you would have gotten 2 values, which is the second and the third value. Now, this last one basically says that you should provide, so you see that it gives you between 0 and 4. But the difference is, how will I put it? It's saying between this, the first and the third value, but give me at a 1 interval. That's these 2 here represents that for every 2, so it will end up giving you A and C. That's what this 2 basically is doing. So you are saying between A and D, give me the first, and then for every other 2. So it will skip 1 and go to the next one. That's what this is basically telling you. Now, this is a for loop. So when you see things like for A in list 1, it's saying you can take it, this A is basically each. So you are saying for each value in list 1, print each. So it will go to the list, it will take the first value, it will print it A, go to the list, take the second value and to print it, and so on. That's just basically it. Then there's something called list comprehension. List comprehension. Now, this is a for loop, but this thing you did in this for loop, you can easily do it within something like this. This is a list comprehension. Why this is a for loop? But they practically do the same thing, but the list comprehension is faster, because what you are saying here in this for loop is that you created an empty list called list 3. And you're saying for each value in list 1, that's this list 1 that we had here. Let me move it. So we have list 1, then we created an empty list, list 3, and you say for X. Now, I like to do it this way because it makes it easier for people to comprehend. For each in list 1, let's say each value. For each value in list 1 dot append each value plus underscore. So as you can see from here, what it's saying is that go to the list 1, take each value, append it to list 3, but before you append it, add an underscore in front of that value and then append it to list 3. So it will do it for every single value within list 1. And then this here now, when you just put this variable list 1 here and you run it, it is similar to when you run a print statement. So in Jupyter Notebook, you can just drop the value of the variable and run it, and it will give you it to print. So when you run this command, it basically prints them individually into this list 3 and then prints it out for you to see. Now that's the same thing that's being done here. So you can see within this list comprehension, what it's saying is that x plus underscore. So we can still say each value, each value. So it's still basically doing the same thing. It's saying for each value in list 1, do this to it. Do each value plus underscore. And remember, it's already inside the list with the square bracket. Then your list 3 gives you this. So that's just basically list comprehension. Then we go to some basic use. I'm not even sure. Do I have the text file? Let me see. Okay, I have the text file. You can see now that what is happening here is that with open, this Shakespeare.txt is a file, is a text file that should be in the same place where your Jupyter Notebook file is. It says open it as F. So this command will open this txt file and store it in the F variable. So now with this second command now, what you are doing now is you are declaring a variable called lines, and you are saying for F, that's that variable, dot read lines. So this line will hold all the lines of the F variable, which is the content of this Shakespeare.txt. So let's run that. Now let's do something so that you understand what's happening here in case you don't. As we have run that now, you know that you can, if you run the lines variable, it shows you everything that's inside what has been held by lines. So these are all the lines within that txt file being held by this lines variable. Now, if you look at the next command, it's saying this seems a little complex, but what I like to do is to break things down. What this command is doing, line dot split, is this. Oh, sorry. It's basically taking each line here and is splitting it wherever it finds a space. For example, this first one will be split here, where there's a space. This one will be split here. So it will, when it splits them, each of the line, then it will calculate how many values has resulted from it. Let me just try and do something and see if I can. Line equals to you can see what I just did now. What I did is I declared a variable. Remember, what is holding all this content is lines. So I asked for the first value, which is this first value. And then I applied this split by space, like I said. You see, it has divided it into 2. what you have here now has been divided into two. Let me try and do it for the second one to give you even more clarity. So you see, this sentence has been split. You see that this /n is what it is called is a new line character. So it means that after this end, this thing goes to a new line. So it's a new line character. So you see that this split, you are splitting it by space. It has split it into individual characters. That's what basically happens here. So when that happens, I can now, let me now do something here. If I then put len here, you can see this is 1, 2, 3, 4, 5 characters. So if you calculate the length, it will give you 5. So that's what really what this thing is basically doing is this. It's doing it for each of the line in lines. And then it will get all, like the first one will be 2. The value you will get is basically 2 plus 5 plus another value. Then it will sum it all up together to get this value. That's basically what this is doing. But you see that it looks so simple. You could have used a for loop to do this and hold this thing in an empty list and then do the addition and stuff like that. Use the append. There's a longer way to do it, but this is short. Now, at
Yes,
this
sir.
point, I will say, do you have a
Before
question?
before you move on,
Okay.
if you don't use the split function, it's not going to
Yes.
count it individually.
Okay. Look at this now. You will see that this thing is 1. They are together. Is a string.
Okay, it's going to count as a sentence.
It's going to count it as just one value.
One value. Okay.
Let me just show you that. Learn lines 1. Oh, okay. Okay. Oh, because it's a string, it counts each individual value. It counts each individual value within it, including the space. That's what it does here. You know that lines, oh, sorry. Oh, yeah, that's what happens. It counts each individual value within. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 20, 29. So you see, that's what it counted. It counted each. It didn't count it as sin, I, London. It counted S as a single string. It counted C as a single string. And that's why you got this value. But what we are trying to see is we are trying to count the words within the text, not the individual letters. We are not trying to count the letters. If you were counting the letters, you wouldn't need to split it. So that's that. Who else has a question or about what we just did now? Anyone? Okay. So when you run it
Hello?
all, yes, go ahead.
So okay, so basically what split is doing there is actually maybe because of the space you put in between, so it counts it based on the bar of word space, like word that is separated by space. It's
Exactly.
key. So,
Yes.
okay.
That's why you see this space. The space is the delimiter.
Okay.
The space is the delimiter.
Okay.
Obviously, you know,
Okay, I
when you
get
are
it.
dealing with what we call a CSV has a comma as the delimiter, while a TSV has a tab as the delimiter.
Okay.
So you're splitting it along. So you can replace this even. For example, if what was differentiating them was a slash, if you put the slash here to split it by that slash, that's what you are telling it to split by space. That's what it's doing.
Okay.
Yeah.
I understand it now.
Okay. Any other person?
If you remove the remove the parenthesis, just length of lines, it's going to count each line in the text, right?
If you remove what?
Line 17. If you remove this, just have length of lines. It's going to count each of the lines in it, right? In the text, in the old text.
Let's just do it now.
Yes.
And see what it counts.
Okay.
What is it counting?
I don't know, man. This is 100.
Yeah?
Are they up to
It's
100
counting the
down?
letters.
Are they up to 100?
It's counting the letters.
Are they
Counted
up?
everything.
What do you think it's counting?
I think
It's
I think it
each
counted
letter.
Counted everything.
Each character.
It's counting each letter.
Yeah?
It's counting each letter, like each character, as it said.
I don't think it's it's not each character. I don't think it's each letter. The reason
each new line.
Exactly. It's counting each new line because the reason you know is this. If you look at when you split, remember when you split, it counts each words.
Yeah, each word, yeah.
Yes. Now, if you look at it, ordinarily, if it's counting each character or each letter, it should have more. It should be more than this.
It should be more than the 101,000.
Yes, it should be more than 101,000.
111, rather.
So
111 actually.
Yes.
Oh,
so
okay, awesome.
basically, what it is working with in this case is this.
Is
Remember,
comma.
yes, after every comma, it's counting. This is 1. This is 2. That's what it's counting.
Hello.
All right.
Yeah, I can hear you. Go ahead.
I don't think. So what I think is that this second one, the line 18, is a sum. So that's why the number is so much. While the earlier one that is just the length is counting all the characters, including the spaces. Don't forget that we've already put the sum function here. Second one, so it's adding everything together. That's why we have a huge number compared to the preceding. That's my thought.
Okay. If we were to let's experiment. I like the fact that we can do this.
Yes, I support that too.
Let's experiment. Let's see.
Maybe we should add some to the line 18.
Hold on, I'm trying. Let me see. Then. Okay. Let's see if I get this right. Let's see. So you can see now. What we basically did here now is this. You can see this is 4,366,000. This now is each letter. Because what I did here is that for each line, I'm telling it count all the letters. This one now, I said count all the letters for each line and add them all together. So I get 4,366,288. While this one says split each line into by the space and count each of those values and then add them all together. We get 815,988. Do you understand now? Does someone have something to say?
Okay.
the only problem I have is that this one that gave us 4 million, we're counting characters. That's each
Yes.
letter.
Yes.
While this other one is counting every word, excluding the spaces.
Yeah?
If I'm right. I said
no, it's including this.
I didn't get that.
I said the latest function or command, the latest command
Yes.
line appears to be counting all characters, all letters.
Yes.
Am I right?
Yes, it is.
While the previous one, the 815,000, appears to be counting the words, having splitted the thing by space.
Yes.
So we shouldn't expect the same the same answer, considering the fact that one is counting letters. What I thought is that we're supposed to count words. I don't know whether I'm making sense.
Well, the only reason we went about this exercise was mainly because of when we did the length for lines. And we're trying to say, okay, what is this giving us? That this 111,396. What was, remember, a length is a count.
Yes.
A length is a count.
All right.
So, sir, to understand it better, sir, for this it's line 18. The length is the line is counting each line separated by a comma.
Exactly.
Like each sentence separated by a comma. That was just counting.
Yes, that's what it's counting.
Okay, sir. Okay, sir.
While this one that is 4 million something is for each line is calculating each word. That's each letter throughout. That's what it's calculating.
Okay, including the space. Is it including the space? Is it including the space?
That I can't be sure if it's counting the space.
I think it should.
I think it should. Yes, it will count the space because
And
the space is the space is a character.
Okay.
The space is a character. It will count the space. Yes.
I think if we do it with a smaller data quantity of data, it might help us.
Exactly.
If we do it with a smaller quantity of data, it might help.
Okay, for this one now, to know if it's counting the space, let's just do something. Learn lines 0. Because we can know now. This is 6, right? So how many? You see, you have acts. Act is 3. I/N is 3. But what I'm not sure of now is the /N. The new line character.
I don't
be 1.
Counting
It's counting the new line character as 1.
Yes, the /N. I think it's counting
the /N is counted as 1, not 2.
1.
So the /N is the new line character.
You know what? So why not just write a new line with just /N alone and check the length? I mean, why not just write a new line, declare?
Okay, let's even do something. I think that's what your short. Let's say we put a space. Then short. Can you see?
Okay, so it's counting the /N as a character.
As
so
one.
Just
so if I run
this /N, let's say. Only /N. Can you try only /N?
Let's see then. /N.
Okay.
Counting it as 1 because Python knows it. It's you know there's a /N, there's /T. It's a new line character. It's just 1. So the space is also 1. If you put a space now, you see that this will be 2. So it counts the space also. So that's that. So this is more or less the same thing. So we now go to this area. Now, what this helps you to
Hello, sir.
do really? Okay, go ahead.
Yes, sir. Good afternoon, sir.
Good afternoon.
My network is not all that from my end, so I want to know if or ask if the meeting video is going to be available after we are done with it, so I can go
If
through
the
it and
what?
listen to it at my late time, because due to poor net, I'm not getting real details from it. So
That's the thing. I didn't even get your question.
Is
Is
asking
asking
if this
if
video, the recorded video, if it's going to be shared on YouTube or any platform, so you
The
can
record.
watch it later.
Okay, of this class.
Yes, of this class.
Yes, the
yes, sir.
it's been yes, it's being recorded, but I don't know how soon. Okay, I'll get that information across to you, but we are recording it. We'll share it on
Okay,
YouTube,
sir.
but I don't know. The challenge is that I don't know how soon it will be shared, because obviously it will go through a process of editing before we share it. So I don't know how soon that will be. So I can't really say. What I can advise you do is uh, this notebook this notebook that I've been able to work on now that we've edited, maybe maybe that can be shared. Maybe that can be shared so that you can go through it, because I can't really tell you if this video will be shared immediately. But I know
Okay,
eventually
sir.
it will be shared. But I don't know if it will be shared on time for you to use it for what you need it for.
Okay, sir. Sir, is there a material to this
Okay, sir.
introduction
Thank you, sir.
that we're supposed to go through also?
Yes, there's a even all. Okay, let me show you something. Let me do something for you here now. Now this is my email. Um, you can see my screen, right?
Yes, sir. Yes, sir. We can see your screen.
Yes, you
yes, sir.
can.
Now you will see an email like this was sent on the 17th of
Yes.
October. Now, no, sorry, not on the 17th. That's the day I sent it to someone. An email like this was sent. Where is that? Now, if you click on this link, take you to a new tab, you'll see something like this.
Yeah.
This is the curriculum.
Mm.
So you see that there's a slide, notes, and video.
Yeah.
What I advise you do is this. There's an error in this in this place, because this slide for introduction doesn't it takes you to the slide for Jupyter Notebook. So what you can do is this: if you right click on the notes, open link, it will bring you to this website. All Jupyter Notebook, like the Jupyter Notebook we are working on now, just click here, you can download it. You can see it, right?
Yeah.
Once you click, it will you see I've already downloaded it. That's why it's showing this is popping up. But once you click here, that Jupyter Notebook will be downloaded as a zip file for the Jupyter class. But if you come here to lectures, you see all those, you see everything. You can now, this is where you find the slide for the introduction. This is the notes, which we just came from now. And this is the video. But I'm not sure if this video link is working. I'm not sure. No. From here, ideally, just go from the video link here is working. If you open the video, it will take you to a page like this. Downloading this video can be quite difficult because of how it is structured. So these are all the videos. This is the introduction video. This is the Jupyter Notebook video. So, for example, this is the data collection and scraping video. That's for next week's class. So you should come here and just watch it. These are all the things we'll be working on. You see, this is the last class we'll have, Introduction to Machine Learning. So this is how you can access all this material. All right, let's return back because we have a few minutes left. Now, what this just basically does is you're basically looking how fast you're looking at using for loops and how fast it is. That's basically what this does for you. So this is timing. It's timing it for you. Then this is a dictionary. A dictionary is basically a list of key value pairs. If you call A to give you the value, so A is the key, A, B, C are keys, Y1, 2, 3 are values. You call the dictionary name, square bracket, key to give you the value. So that is basically it. This is a dictionary comprehension. The same way we had list comprehension here. This is a list comprehension.
Hello, sir.
This is a list comprehension. Yes, I can hear you. Go ahead.
This percentage, what does it actually mean?
What do you mean?
Hello?
Percentage.
The percentage Hello? I'm seeing there, like the total percentage in line 20.
Like I told you, they are called magic. Hello?
Magic.
They are called magic. It's not magic. It's not Python.
Oh.
Hello? It's not Python. It is native. This thing you are saying, like this time it is native to the Jupyter notebook.
Okay.
They are not Python commands. What basically this does is anything that runs here now, it will basically give you the time it took for each line to run. That's what this one does. There are plenty of them. You can find documentation about them online. It's not, these are not Python commands, so it's not something you need to cram.
Oh. Okay.
There's only one that I know that you use regularly, which is what I showed you earlier, which is this one. This is Matplotlib inline. Because you see, if I don't use it, this thing will not show here. This visualization will not show here. So that's what this one is used for. So there are plenty of them. It's not even me. Nobody crams it. If you need it, you just Google it and you find what you need for what you need it for. So these ones are basically dictionaries. I don't think I want to. This is a dictionary comprehension basically. I raised to power 2 for I in range. This is just a dictionary comprehension. So it shows you 0, 0, 1, 1, and stuff like that. It's fairly similar to a list comprehension. Then you have things we call class. I don't know how to. A class basically assembles different functions. That's why it was important that you went through the solo learn module that you were asked to go through. You should have been introduced to things like this, like what a class is, what it does, and stuff like that. So you can run these things in. Basically, what this one does is that the name of the class is called my class, and basically it has a value, only one value. It takes in one value, n, and you can get n and stuff like that. Don't want to go through the whole what self is and stuff like that. You can read up on that. Now, one important thing that is really essential in this particular cohort and in this data science class, because of the fact that we are not doing machine learning, most of your projects will involve a data visualization part of it. And what you'll be using a lot is Matplotlib, and obviously you should know about NumPy. I think we'll make available videos for you to learn NumPy if you've not. If you need help with that, we can make videos available, because that's not the essence of the classes. And please, you should practice NumPy, because when you get to week, although on the 14th, it's supposed to be on the 14th of November, but that class we hold on the 7th. That's vectors, metrics, and linear algebra. You need NumPy for that. It will hold on the 7th of November. We are switching these two classes, and Brain will be handling the class on the 7th because I won't be available for that class. So please go and you have to read up on, practice a bit on your NumPy. So that's basically this, what you can do in Jupyter Notebook. You see the Matplotlib inline notebook. Now, you'll notice something. There's a Matplotlib notebook, then there's a Matplotlib inline. The problem is that sometimes you don't necessarily use this one a lot because this one helps to bring, make it more interactive. But what you use the most is this one, Matplotlib inline. It just gives you a static image. So that's how Jupyter Notebook works. And there are other smaller things that you do. For example, if you want to have a new cell, once you click on a particular cell, escape. If you press A to give you a cell below, if you press B to give you a cell above. So all these commands, you can find them online, and really, but they are not things that you cram necessarily. But you can go through the course materials that we provided and to get as much information as you want. So now, in the next, we have about 20 minutes, 10 minutes left. So I would like to take questions.
Okay, sir. So how do we submit our assignment, sir?
The part about the assignment, obviously, when the assignment will be given.
They are giving us, there is sending assignment.
Some has been sent to our mail, like 2.
2 years.
Okay, 2 assignments have been sent to your mail.
Yes,
now, like I said, Kene will, I don't know if it's today, he'll take you through the process of submitting. There's a platform that I need to get confirmation on that because we're supposed to alert the professor. We sent him an email. I don't know if he has gotten back to us. There's a platform that's Digidroid that we use to submit assignments. So that it will be communicated to you before you need to submit it.
Okay, sir. Okay. Yes. Thank you very much.
Who else has a question? I thought I saw something. Okay. Okay.
Sir, the projects will be done. Will it be a collective? Will it be done collectively or individually? Projects.
No, projects are individual.
Okay, sir.
Yes, I was the one that sent that input now in the chat room.
Okay.
The one that you're working on right now. Can you hear me?
Yes, I can hear you. Let's
yes.
run.
That one that I think is the same thing. Is still there. I saw it in the solo run. That's why I'm writing it there. In that line 2, it's actually 2 equals sign.
Yeah.
Yes.
Yeah.
Equals sign. Yes. I saw it in the solo run and I'm confused.
Okay.
Because it has that percentage I'm looking at.
Okay. This is how it should be. But the problem with this is that there's no value for x. Okay. Well, let me explain some. Let me see if you missed out on anything. Let me look at it here.
Probably.
I'm sorry. I think he's asking about the percentage sign. That's what he's most concerned about.
I think
that one is just about
this one.
Yes.
This one basically
yes.
talks about now. Let's say x is 10. Let's say x is 10. X equals to 10. this value will return a true value. The reason is this. What this gives you basically is it's basically saying what is the remainder. You know, when you divide x divided by 10 doesn't give you any remainder, right? The remainder is 0 because it's a whole number. Can you hear me?
Yeah, I can hear you. Go on.
So what this percentage sign is doing here is asking you, is there a remainder when you divide? So basically saying, is this an even number? Because you are dividing by 2. What the value, this value, instead of, okay, x, which is 10 divided by 2 gives you 5, right? But when you use this value, this percentage sign, what you are looking for is not the 5. Is there an additional value? For example, 11 divided by, okay, let's just do something so that you know what it does. And x equals to 11. X. Can you see?
Okay.
Can you see what that sign does?
It returns the remainder.
It returns the remainder. Remember, yes, the remainder is 1. That's what that sign does.
Oh, okay.
Yeah, it returns the remainder instead of the value. It's what the remainder is. That's what it will return for you.
Okay.
So that was why it was important that I point out that those things, those ones that you saw before the time, has nothing to do with this because that is not Python code. That has to do with Jupyter Notebook, but this stuff in Python, this is what it does.
Okay.
All right. Who else has a question so that we'll wrap this up, or a contribution? So we don't have any other questions or contribution. Okay, that's fine then. Brain, are you there? So if that's the case, if it turns out we don't have any other contribution, I want to thank each and every one of us for participating today. But like I said earlier on, I like the fact that today's class was quite interactive. But like the individual who dropped that question, what it shows is that you actually participated and you went through your solo learn. Because that you got confused is a good thing. Now it is unlikely that you will forget what this thing means now. But if you had not gone through it, you wouldn't have. I'm encouraging things like this. Go through the material so that you can have this kind of questions. We can treat them in the class. We can have a good dialogue. Because since we are not seeing each other as in person and we are doing this virtually, it's important that the class is as interactive as ever. Because sometimes when I'm talking from where I am, I'm wondering, are they getting it? Do they understand, or am I just talking to myself? So I like the idea that you go through the material so that you can engage with me. I am not afraid of being wrong. You can, even if you read so much and you get something and you think that something I said is wrong, that's allowed. I am allowed to be wrong. You can correct me, it's allowed. But you won't be able to correct me if you yourself don't do your own homework. So please, in subsequent classes, before next week Saturday, please let's go through the materials we have so that we'll have something similar to today where it was quite engaging.
Sir, suggestion, sir.
Okay, please.
Because some of us had it quite difficult navigating through to find the videos, the things we are meant to read. Because honestly, I didn't know we were meant to read anything. I didn't get the email. It was just now that someone put me through on how to get there. So I feel once it's the link is sent next time, just to probably a short meeting to put us through how to get there beforehand, so that once you just come, everybody will be.
That's why I went through the process earlier on. You can see
Yes,
my
yes,
screen,
I
right?
understand. Yes, yes. No,
So,
because I feel by now most of us should have gone through it, but virtually
well,
50% hasn't.
Remember, it's not too late. When I say go through, I was talking about today's class. So I'm saying go through the one for next week's class. Usually the first classes, we have a tendency to have these kind of challenges. But the thing is, by the third class, I don't expect that anybody will still be, because these are teaching challenges. Obviously, they could have missed out on somebody's email while sending them and stuff like that. So what you can do is send an email over. If you didn't get the link, send an email to Kenny Duko at Gmail. I think you've received emails from him before, and the links will be sent to you, or you can reach out to me on Slack, and we'll find a way of getting. Or you could even chat with your colleagues on Slack.
Yes. They forwarded the mail to me. Yes.
So please, what I'm encouraging us to do is that before next week's class, let's go through next week. Let's look at the schedule. Next week we are going to be dealing with data collection and scraping. As you can see on the screen, data collection and scraping. Data scraping is actually a very, very interesting one. You would enjoy it. So let's look through the material and come loaded with questions, so that we can make it as interactive as possible. So I want to thank each and every one of us for participating today. I think I saw.
So can we ask questions like for next week class now? Can we ask questions regarding this week's class? Because as I said, some have not gone through the materials. So we're going through material. We have some questions now that will pop in our mind.
Okay, so what I would do is this: the first 10 minutes of next week's class, 10-15 minutes, we'll spend it trying to, whoever has questions from last week's class, we'll try to attend to it. Is that fine?
Yes, sir, it's fine, sir. Thank you, sir.
Okay. For those who say they are yet to get the assignment, please, I know you've gotten communications from us before. Send an email to that email address, or reach out to us on Slack. Send an email to Kene so that you can get the assignment. I'll be surprised. I'm surprised that you have not gotten it, but I will take note of the two people who have not gotten it, so that I can communicate with Kene myself. Also, Abubakar Yakov. I want to believe that this is your actual name. Then yes, please.
I haven't. So
I think a lot of us are
please, if you've not gotten, what I advise you do is send an email. There's an email we use to communicate with you regularly. Send an email to that email address telling them that you've not gotten your email address, and also drop that information on Slack.
All right, sir.
Okay. Thank you very much. So I'll see you guys same time next week, Saturday. Enjoy the rest of your week, and please revise this material. Let's make it as engaging as today's one was. I want more. It's a few people that really participated and engaged with me. I want the whole class to be bubbly next week, because everybody actually went through them. Thank you very much.
For the next week class,
thank you very much.
Hold on, someone is asking a question.
For the next week class, do we get another mail for the link?
No, the link. Hold on, the link has everything.
No, I'm asking for next week's class now. Are you still using this link for
the Zoom?
Yes, for the Zoom.
Yes, it's the same.
Okay.
Yes. Okay. All right. Thank you, everyone. I appreciate you guys.
Thank you so much, sir.
Week. Okay. See you next week.
Thank you very much, sir. Thank you.
Bye.